Hello, Caymans, Mr. Eicher back with a part 2 lesson on radical operations 5.5. We're going to look at, there are two problem types here, and then we have a third problem type at the bottom. So we have about, what, 2, and then you have a try this, 2, and you have a try this, and then 2, and you have a try this. And then there's a third page of these notes, and that'll probably just be a separate video. So we've been working with radicals. First one is when multiplying binomials. Binomials, you have two terms separated by a plus or minus, like these two are called binomials. We use the distributive property and then simplify. So we're going to check out number 11 first. We're going to distribute the 5 times 5, and then 5 times square root 2. So 5 times 5 is 25. 5 times square root 2 is just going to be 5 times square root 2. 5 times square root 2. The 5 doesn't multiply inside the radical. Sometimes students ask that, like, do we get a 10 or something? It would have to be like this, square root of 5 times square root of 2, to be able to multiply them to be square root of 10. And we don't have that here. It's just a 5 without a square root. So we get 5 times square root 2. And then we distribute the next set. So we're going to multiply these two. That would be a negative 5 square root 2. And then multiply these two. Now notice they both have radicals. This one and this one. Square root 2 times square root 2 would be minus 2 times 2 is 4. So minus square root of 4. And then we can add like terms. So these two are like radical expressions. So to be able to combine those, if you have 5 root 2 minus 5 root 2, that would be 0. No more root 2's anymore. So you have 25. And then plus 0 root 2's. And then square root of 4 is just 2. Now 0 root 2, that's just 0, so we really don't need that. So this is 25 minus 2. So the answer is 23. Looking at the next one, same idea. We're going to use the distributive property. So we're going to distribute square root 3 times square root 3 is square root 9. You could just write that as a 3 immediately if you want. And then square root 3 times 4. You'd put the constant, the 4, out in front as a coefficient, and you have square root 3. And then 4 times square root 3 would be plus 4 square root 3. And then 4 times 4 is 16. So we can simplify. Square root of 9 is 3. We have like terms, 4 root 3 plus 4 root 3. We can add those. That's going to be 4 plus 4 is 8 square root 3. Sometimes students will want to know, like, what happens to the square root 3 times square root 3? Like, do we have to do anything there? And we don't, because it's basically like this. You have 4 of something plus 4 of something. That would just be 8 of that something. So it's the same idea here, where the x is just a square root. 4 root 3 plus 4 root 3 is 8 root 3. And then we have plus 16. We can also add these like terms. We should do that. 3 plus 16. So that would be 19 plus 8 root 3. And that would be our answer. It's more common to put the constant, 19, out in front and put the radical part second. So whenever you type your answers, type the 19 plus 8 root 3. And for number 13, you can try that as a try this. So let's move on to the next part. Adding and subtracting radicals. We were actually kind of already adding and subtracting radicals, if you follow that. You can only combine like radical expressions, which means that the indices, the indexes, and the radicands, the part under the radical, have to be exactly the same. So for instance, the indices here are 2's. Those are exactly the same. And the radicand, those values are exactly the same. So when we combine these, this would equal 11, 4 plus 7, square root 2. So let's try some of these. Number 14, simplify this. Tricky part here is just make sure you simplify completely. So with 18, we're looking for pairs. So 18 is 2 times 9. 9 is 3 times 3. We have a pair of 3s, so we're going to take a 3 on the outside of the square root, and we're left with that 2 on the inside, that 2 right there. And then for 50, we would write 50 as 25 times 2, and that would be 5 times 5. So we have a pair of 5s. Really, you could stop right here and know that you can take the square root of 25. Or you could stop right here and know that you can take the square root of 9. But if you want to go all the way down and find pairs of factors, you could do that too. So we have -5, and then the square root of the leftover stuff, square root of 2. So we can then combine like radical expressions. Both of these terms have a square root of 2. So we do 3 minus 5. So -2, square root of 2. That's it for that. Number 15, we have 3 terms. So again, we have to be careful to simplify them completely. So we have 98. So that's 49 times 2. And 49 is a perfect square. And then 72, we have 36 times 2. And 36 is a perfect square. And then 32 is 16 times 2. And 16 is a perfect square. So another way to think of these square roots, when you're square rooting values, we're just breaking it up into factors, and we're looking for, can we square root one of those perfect squares? So these values right here are perfect squares, so you can square root those. So that first one would be 7 root 2. Then we get 6 root 2. Then we get 4 root 2. So using that to answer this, we'd have 7 root 2 minus 6 root 2 plus 4 root 2. And they all have identical radicals, identical indices on those radicals. So we do 7 minus 6 plus 4, so that would be 5 root 2 is the answer to that. So hopefully by the end of this lesson, you'll get really good at simplifying square roots and cubed roots and stuff like that. Number 16 is one for you, so you can answer it right now, and then you'll be ready when you do the try this later today. So number 16 is for you. Last thing we have is simplifying sums or differences of radicals in the denominator multiplied by the conjugate of the denominator. So if we have radicals in the denominator, it's not simplified. So to be able to simplify, we multiply what's called the conjugate. So to find the conjugate is the opposite sign that separates the binomial terms. And that's the only one that you make opposite. So the conjugate of this would be 2 minus square root 3 is known as the conjugate. Or the conjugate of this one, you just do the opposite of that sign. So that would be 3 plus square root 7 is called the conjugate. So let's see what this looks like. Our goal is to get rid of this square root in the denominator. But that 1 minus square root 3, that 1 minus part's kind of in the way. So what we do is we multiply by the conjugate. We're going to multiply the top and the bottom, both of them, by the conjugate. The conjugate would be 1 plus square root 3. So we're multiplying that in the top and the bottom. And again, that's called the conjugate. Looks like conjugate. Maybe you see that in Spanish or French. Conjugate a verb, but this is conjugate. So when we multiply, we're going to be multiplying these. So the 2, we're going to distribute the 2 to both of those. So that would be 2 times 1 is 2. And 2 times root 3 is 2 root 3. In the denominator, we distribute, multiply, distribute the 1. So that would be 1 plus root 3. And then distribute the square root 3. So that would be minus root 3 minus root 3 times 3 is 9. Now the reason why we multiply by the conjugate is if you chose the conjugate correctly, this middle term here will always equal 0. That plus root 3 minus root 3 is 0. And then this radical, that will always be a perfect square. So what we get for an answer is 2 plus 2 root 3, that's the numerator. We have that 1 plus 0 that we got, and then minus the square root of 9 is 3. So again, the reason why we multiply by the conjugate at the beginning is to get rid of the radical. So notice there's no radicals left, no radical in denominator. And that was our goal. We want a rational denominator, not an irrational denominator. And then I think we can just simplify this a little bit more. We have that 2 plus 2 root 3 divided by negative 2. And we would divide the 2 with these 2's. So that would be 2 divided by negative 2 is negative 1 minus 1 root 3. So our answer would be negative 1 minus root 3. So that's the process of multiplying by a conjugate to be able to rationalize the denominator. Let's look at another example. I'd encourage you pause the video, see if you could figure out what's the conjugate. For this one, what do we multiply the top and bottom by? The conjugate would be, the conjugate is the opposite of the denominator, the opposite sign between the terms. So we're going to multiply the top and the bottom by 4 plus root 3. And when we multiply those, we're going to need parentheses since we have a binomial times a binomial. And then we have some distributing to do. So we have 2 times 4 and 2 times root 3. That would be 8 plus 2 root 3. And we have root 3 times 4. That would be plus 4 root 3. And we have root 3 times root 3. That would be root 9. The square root of 9 is 3. Same thing, distributing in the bottom, 4 times 4. That would be a 16. 4 times positive root 3. That would be plus 4 root 3. Root 3 times 4 is minus 4 root 3. And negative root 3 times positive root 3 would be minus square root of 9, which is 3. And notice again, the reason why we chose to multiply by the conjugate is because we get a 0 for that middle term. And then notice there's no radicals now in the denominator. And that was our goal, not to have any radicals in the denominator. So we can add like terms. We would have in the numerator, we have 8 plus 3 and 2 root 3 plus 6 root 3, or plus 4. So that would be 6 root 3. The denominator is 16 minus 3, so 13. We'd leave the answer like that. You could see the answer written like this. This is equivalent, and this is still correct. Divide each term by 13. Sometimes we might give you that pattern on Schoology. Sometimes we just might ask what's the numerator and what's the denominator. So the numerator would be 11 plus 6 root 3. The denominator would be 13. So we could ask that. But that would be our answer. And the last one, number 19, is a try this practice problem for you. I think that's good for this video. Thanks for watching, and I'll see you in the next video.